Welcome back to the deep dive. Today, we are taking you on a trip to a bustling tropical market. Just, imagine you're walking through the stalls looking at all the vibrant produce, and your eyes land on this massive green, kind of dinosaur-looking thing.
Yeah, they really do look completely prehistoric.
Right. It is incredibly sticky. It's covered in these little blunt spikes, and it can easily weigh like up to 40 pounds. You probably know it as the jackfruit.
Oh, yeah. Hard to miss.
Totally. Well, imagine finding out that the secret to managing a global metabolic crisis was hiding inside that exact sticky, spiky fruit, just waiting to be dried and ground up.
It does sound a bit like a fantasy novel premise, honestly.
Yeah.
Yet, when we comb through the clinical data today, the physiological impact of this specific plant on human metabolism is just undeniable.
And to be clear on our mission today, we are not talking about the sweet yellow ripe fruit that you might find in like a vegan dessert or a smoothie bowl.
Right. No, that's totally different.
Exactly. We are pulling from a really fascinating stack of sources, including a randomized, double-blind clinical trial, an animal study on metabolic homeostasis, and some pretty comprehensive food science reviews. And our focus is entirely on the unripe green jackfruit and its often discarded seeds.
Which is a really crucial biological distinction to make right up front. Because, as the fruit ripens, the complex carbohydrates break down into simple sugars.
Right.
So the ripe fruit is fundamentally a different entity nutritionally than the unripe fruit or the seeds. It has a completely different glycemic profile.
So we're going to uncover how simply replacing a tiny amount of everyday flour with green jackfruit flour acts as a highly effective medical nutrition therapy for type 2 diabetes.
Yeah, it's pretty wild.
And beyond just the clinical application, we're looking at how valorizing agricultural waste, literally taking the parts of the fruit we currently throw in the trash, could basically revolutionize the commercial gluten-free market and global food sustainability.
It's a huge shift in how we look at food systems.
Definitely. But to prove this isn't just some passing wellness fad, let's jump straight into the hard clinical data. We have a study here from the Rajiv Gandhi Institute of Medical Sciences, and this ran from May 2019 to February 2020.
Yeah, and this was a rigorously designed, randomized, double-blind, placebo-controlled trial. They took 40 patients who had been diagnosed with type 2 diabetes for over a year.
Okay.
And a critical factor here is that these patients were already taking oral blood sugar medications. So the researchers were not looking for a pharmaceutical alternative. They were testing an adjunctive nutritional intervention.
Got it. And the intervention itself seems almost aggressively simple. I mean, they had these patients replace an equal volume of their regular rice or wheat flour with just 30 grams of green jackfruit flour every single day.
Just 30 grams, yeah.
And that volume was split up, right? Like 15 grams at breakfast and 15 grams at dinner. And they maintained this protocol for 12 weeks.
They did. And the clinical endpoints were remarkably clear. I mean, the patients in the jackfruit flour group saw a 0.25% drop in their HbA1c.
Wow. I mean, for anyone tracking glycemic markers, a 0.25% reduction from a purely dietary swap of that size, that's highly significant.
Oh, absolutely.
We also saw their fasting plasma glucose drop by nearly 30 milligrams per deciliter, and their postprandial glucose, so after eating, dropped by almost 37 milligrams per deciliter.
Yeah. Meanwhile, the placebo group, who simply maintained their regular wheat or rice flour intake, they actually saw a slight increase in their HbA1c over that same 12-week period.
I do have to offer a little skeptical pushback on the sheer volume of that swap, though.
Sure, go for it.
Because 30 grams of flour is essentially just a couple of spoonfuls. It is a minuscule volumetric fraction of an entire daily diet. So my instinct is to question how such a tiny adjustment can actually move the needle on long-term blood sugar markers like HbA1c. I mean, it almost sounds like a statistical anomaly.
No, it's a totally valid skepticism. But, it highlights the underlying mechanics of medical nutrition therapy. The efficacy isn't just about the total volume of the swap. It's about the compounding effect of daily repetition and the strategic timing.
Okay, timing. How so?
Well, 15 grams at breakfast and 15 grams at dinner isn't a lot of food, right?
Yeah.
But you are consistently altering the glycemic load during the body's two most vulnerable postprandial windows.
Oh, I see.
Yeah, so you're fundamentally changing the chemistry of digestion twice a day, every single day for 3 months.
So it's less about some massive dietary overhaul and more about like a surgical strike on how the body processes carbohydrates during those specific morning and evening spikes.
Precisely. That is the exact right way to look at it. And another fascinating detail of this Rajiv Gandhi study is that this normal glycemia was achieved without any significant weight loss among the cohort.
Which really challenges that persistent clinical stereotype that type 2 diabetes must be treated exclusively as a disease of obesity. Yeah.
Exactly. The clinical profile of diabetes varies drastically depending on the population. In India, for example, over 30% of patients with diabetes are classified as non-obese.
Wow, 30%.
Yeah. The South Asian population often exhibits a much higher risk of insulin resistance at a significantly lower body mass index. So dietary interventions that regulate blood sugar without requiring massive caloric restriction or weight loss are just vital for this specific demographic.
And the genius of the trial design is the ease of adoption. Like, they didn't hand these patients a strange powder and tell them to drink it with water.
Right, which people always hate doing.
Exactly. The patients literally just mixed this green jackfruit flour into their traditional batters for roti, idli, or dosa. The sensory profile of the food didn't change. Their cultural eating habits remained completely intact, but their blood sugar markers plummeted.
And, compliance is the graveyard in most dietary therapies. By engineering this as an invisible swap, they practically guaranteed the patients would maintain the protocol over the 12 weeks.
Okay, so now we need to look under the hood. Why is this green jackfruit flour so profoundly more effective than the wheat or rice flour it replaces?
Well, it comes down to a complete structural difference in the carbohydrate matrix and the dietary fiber. Let's look at the glycemic index first.
Okay.
Ripe, sweet jackfruit has a high GI of 75, but unripe, green jackfruit, has a low GI of just 40.
And when you cross-reference that GI drop with the macronutrient breakdown of the 30-gram serving used in the trial, the contrast with traditional flour is just stark. Like 30 grams of green jackfruit flour contains about 108 calories, 20 grams of net carbs, and 4 grams of dietary fiber.
And compare that to the placebo wheat or rice flour, which came in at 146 calories, 30 grams of net carbs, and only 2.5 grams of fiber.
So you are looking at 25% fewer calories, 33% fewer carbs, and a massive 57% more fiber.
Yeah, the macros are totally flipped.
It makes me think if traditional refined flour is like throwing a cup of gasoline on a fire, causing a rapid, unmanageable blood sugar flare-up, this green jackfruit flour is like throwing a slow-burning log on the fire. It provides the necessary energy, but in a slow, controlled time release.
I like that analogy. And that slow-burning log effect is mechanically driven by the specific ratio of soluble to insoluble fiber.
Okay, break that down for me.
So, green jackfruit flour has a notably high concentration of soluble fiber. When that soluble fiber enters the aqueous environment of your digestive tract, it binds with water and forms this highly viscous, almost gel-like matrix.
A gel? In your stomach?
Yeah, exactly. And this gel physically coats the lining of the stomach and intestines. So it mechanically obstructs the digestive enzymes from rapidly cleaving the carbohydrate chains, and that subsequently throttles the rate at which those simple sugars enter the bloodstream.
So it is physically putting the brakes on digestion. But there's a chemical side to this as well, right? Because the sources highlight that the green flour is packed with bioactive compounds like carotenoids, flavonoids, and various antioxidants.
Oh yeah, lots of them.
So are those bioactives acting on a cellular level to manage the severe oxidative stress we typically see in diabetic patients?
They absolutely are. The literature specifically notes that these antioxidants strongly inhibit lipid peroxidation.
Which is what, exactly?
Well, in a state of chronic hyperglycemia, the body produces an excess of free radicals. These free radicals basically steal electrons from the lipids in our cell membranes, causing severe structural degradation to the cells.
Oh, yikes.
Yeah. And this oxidative stress directly damages the pancreatic beta cells and exacerbates systemic insulin resistance.
So by inhibiting that lipid peroxidation process, the jackfruit flour is essentially acting as a cellular rust-proofing agent.
That's a great way to put it.
It's slowing down the sugar spike mechanically with the viscous fiber gel and simultaneously protecting the cell membranes chemically with the flavonoids.
Exactly. It is a multi-pronged therapeutic mechanism.
It's amazing that the flesh of the green fruit does all that heavy lifting for blood sugar. But the irony of the jackfruit is that the part with the most aggressive metabolic properties isn't the flesh we eat, it's the 15% of the fruit we currently throw directly into the landfill.
The seeds.
The seeds.
Yeah. This is where the scope of the research shifts from managing a single disease to rethinking how we utilize entire agricultural supply chains. Because historically, the seeds are viewed entirely as a waste byproduct.
And to understand the magnitude of what we've been throwing away, we need to examine an animal study from the sources involving Swiss albino mice. In this trial, the researchers focused specifically on jackfruit seed powder, or JSP.
Right.
They took these mice and put them on a high-sugar diet. And we are talking extreme dietary conditions here.
hmm
30% of their total caloric intake was pure sucrose.
And just for context, a dietary protocol like that is specifically engineered to rapidly induce severe metabolic dysfunction.
Like doing it on purpose to see what happens.
Exactly. The high sucrose load aggressively drives de novo lipogenesis in the liver, leading to obesity, systemic inflammation, and hepatic steatosis, or fatty liver.
But then the researchers added 20% jackfruit seed powder to this high-sugar diet, and the results are just wild. The mice consuming the seed powder saw a significantly reduced body weight gain,
Even on the sugar diet.
even on 30% sugar. Their liver weight dropped, completely preventing the initial stages of that hepatic steatosis. They saw a reduction in both white and brown adipose tissue,
The fat tissue, yeah.
and their lipid profile improved across the board. Lower total cholesterol, lower triglycerides, and lower LDL.
We are looking at a comprehensive physiological reversal of the expected metabolic damage from a high sucrose diet.
My initial thought reading this was that adding the seed powder acted like some sort of magic metabolic erasure, just canceling out the sugar.
It feels like it should be magic, right?
Yeah, but looking closely at the data, it didn't chemically erase the sucrose. It acted more like a digestive bottleneck. The seed powder physically swelled in the gut and basically forced the mice to stop eating.
Yeah. The researchers noted a dramatic reduction in overall food intake among the JSP group.
Yep.
Because the seed powder is so incredibly dense in dietary fiber, it causes significant gastric distension.
Meaning it stretches the stomach out.
Exactly. And this physical stretching of the stomach triggers vagal afferent signals. Those are the nerve pathways communicating between the gut and the brain, which aggressively upregulate satiety.
Which is further evidenced by a really fascinating behavioral change in the mice. Their water intake went up significantly.
Right. And that's because the hydrocolloid properties of the dietary fiber have a massive water binding capacity.
Okay.
So as the fiber absorbs liquid in the gastrointestinal tract, it prompts a physiological thirst response in the animals.
So they were eating a diet that was 30% sugar, but they were simply consuming drastically less food overall because the fiber induced a state of persistent fullness.
Yeah, they just didn't want to eat anymore.
The fiber prevents overeating, slows down the absorption of the sucrose they do consume, and physically binds to cholesterol in the digestive tract, preventing it from being reabsorbed into the bloodstream.
It really highlights how mechanical satiety can override poor dietary composition.
Understanding the clinical data is one thing, but translating a slimy, discarded seed into a functional flour requires a massive leap in food science.
Oh, absolutely. It's not a simple process. The sources detail a highly specific multi-stage processing journey.
Walk us through it.
Well, for the flesh of the green jackfruit, the process involved cleaning off the latex sap, steaming it for 8 to 10 minutes to halt enzymatic browning, sun-drying it to reduce moisture content, and then milling it into a fine powder.
And the seeds require an entirely different processing pipeline, don't they?
Very different, yeah.
After cleaning and drying them at 60 degrees Celsius for 24 hours, the protocol requires roasting them at a rather intense 120 to 150 degrees Celsius. I assume that high heat roasting phase is strictly necessary to denature anti-nutritional factors like tannins and phytates.
Spot on. Raw jackfruit seeds are loaded with these anti-nutrients. If you were to just dry and grind them raw, the tannins would impart a highly astringent, bitter flavor.
Yuck.
Yeah, not great. And worse, the phytates would actively bind to essential minerals in your gastrointestinal tract, effectively blocking their absorption. So the high heat roasting denatures those compounds, making the seeds nutritionally bioavailable.
And it also triggers the Maillard reaction, right? Developing that complex, nutty flavor profile that makes the flour actually palatable for commercial food applications.
Yes, the Maillard reaction is essential for consumer acceptance. But the food science goes even further than just roasting. The reviews detail extensive experimentation with microbial fermentation of the seeds.
I saw that. They are inoculating the seed matter with specific strains of lactobacillus bacteria before the final milling process.
Bioprocessing through fermentation is such an elegant solution to further optimize the nutritional profile.
How so? What does the bacteria do?
Well, the lactobacillus bacteria synthesize enzymes that aggressively cleave the remaining phytic acid. And this breakdown dramatically increases the bioavailability of the protein trapped within the seed matrix. It also introduces significant probiotic potential to the final jackfruit seed flour.
Once it goes through this bioprocessing alchemy, the nutritional profile of this jackfruit seed flour, or JSF, is staggering. You are left with a flour that contains between 13 and 17% pure protein.
That's incredibly high for a fruit seed.
Right. And it is packed with essential amino acids like leucine and valine.
And the presence of leucine and valine is particularly noteworthy. These are branched-chain amino acids critical for muscle protein synthesis and tissue repair, and they are notoriously deficient in traditional cereal-based flours like wheat or corn.
Beyond the protein, the JSF is exceptionally high in resistant starch. Because resistant starch avoids enzymatic breakdown in the small intestine, it travels intact to the colon, where it acts as a potent prebiotic, feeding the beneficial microbiome.
And that high concentration of resistant starch is exactly why food technologists are eagerly adopting JSF in the commercial space, specifically as a structural blending agent.
Yeah, I know they are blending 30 to 50% jackfruit seed flour with rice flour to manufacture gluten-free pasta.
Which is huge.
It is, because gluten-free pasta is notoriously difficult to engineer. Without the gluten protein to bind it, the starch gel is usually weak, resulting in pasta that is either unpleasantly mushy or, gritty.
Yeah, nobody likes that texture. But the rheological properties of the resistant starch in the jackfruit seed flour solve that exact structural problem.
How does it fix the mushiness?
The high amylose content creates a much stronger polymer network during the extrusion process. So it gives the gluten-free pasta the firmness, elasticity, and bite that you typically rely on wheat gluten to provide.
The functional applications seem pretty endless. The reviews mention testing JSF in baked goods, cookies, and even as a plant-based protein extender for meat analogs like vegetarian sausages, where the fibrous texture mimics the mouthfeel of animal protein.
It's extremely versatile.
But zooming out from the food science for a second, the implications for global sustainability might be the most compelling part of this entire deep dive.
I agree. The economics and environmental impact of our current agricultural system are reaching a breaking point. We are heavily reliant on monocrops like wheat, corn, and soy,
which require intensive agrochemical inputs, massive irrigation infrastructure, and just vast tracts of arable land.
Exactly. Jackfruit, by stark contrast, is a highly resilient, drought-resistant tree crop. It requires minimal fertilizer, thrives without heavy pesticide use, and a single mature tree can yield an unbelievable tonnage of biomass every single year.
And the true sustainability victory here is the implementation of a circular economy. Millions of these trees are already being cultivated purely for the sweet, ripe fruit.
Right, the stuff you buy at the store.
Yeah. And the green flesh from the thinning process and the thousands of pounds of seeds generated during processing are currently treated as a logistical liability. They're just a waste stream that costs money to dispose of.
It's crazy when you think about it.
By figuring out the food science required to valorize the unripe fruit and the seeds, we are taking an enormous agricultural waste stream and converting it into a high-protein, low-glycemic, commercial superfood commodity.
And we are achieving that without needing to clear or plant a single extra acre of agricultural land.
The supply chain already exists, we just haven't been utilizing it.
It is the definition of agricultural efficiency. We are extracting maximum nutritional value from existing resources while simultaneously mitigating the environmental burden of food waste.
We started today looking at a shockingly simple dietary swap, just 30 grams of flour, to strategically manage postprandial blood sugar spikes in patients with type 2 diabetes.
Yeah, a tiny change with huge clinical results.
And by following the science, we ended up uncovering an entirely new, sustainable, gluten-free commodity engineered from the exact parts of the plant we used to just throw in the compost bin.
It perfectly illustrates how some of the most innovative solutions in clinical nutrition and sustainable agriculture don't require synthesizing novel compounds.
Right.
Sometimes the answer is already growing right in front of us, simply waiting for the scientific community to analyze it correctly.
Which brings us to a final provocative thought for you to ponder. The jackfruit shows us that our greatest medical and nutritional breakthroughs might not come from a high-tech laboratory. They might just come from finally learning how to fully utilize the natural resources we've been recklessly tossing aside. If the adjunctive therapy to a global metabolic crisis was hiding inside the sticky, spiky seeds of a tropical fruit, what other agricultural waste products in our global food system are secretly superfoods, just waiting to be unlocked?